Hi, in this video you'll learn about constructing a normal probability plot. And the reason we actually use a normal probability plot is to determine if we're given a sample set of data, if we can adequately model it with a normal distribution. So here's an example. 10 observations on the effective service life in minutes of batteries used in a portable personal computer are given below. So I've written them out here for you. Here they are. There's 10 battery lifetimes in minutes. And I'm trying to determine then, can this data set of battery lifetimes be modeled by a normal distribution? Now, in previous chapters, we learned different techniques for graphing data and looking at data. So definitely you could draw a histogram of this data, a stem and leaf, a dot plot. But the problem, they might not be very reliable at being able to determine if a normal curve would fit this data. Especially if your sample size is small, the method of constructing a normal probability plot is certainly more reliable. And so that's why we're going to talk about it and constructing one in this example. So what I did first is this is how you would do it, I ordered the data in ascending order. So here's my ordered data set. And then in the far right column, I have the observed cumulative frequencies. And the way I found these is I ordered the data from, again, small to large, and the position number or the rank number they sit in that data set goes from 1 to 10. So to find the observed cumulative frequency, I took their position number. For example, for this first data point, I took 1, subtracted 0.5, and I divide by the number of data points, which in this case is 10. So not surprisingly, the data goes by 0.10 from 0.05, 0.1525 all the way down to 0.95. So now in order to tell if a normal distribution adequately models this data, I'm going to go ahead and plot the ordered data against the observed cumulative frequency on normal probability paper. So I have the normal probability paper on the next slide. Let me go ahead and move to that. So what I'm looking for, as you can see, the scale is adjusted to be appropriate for the normal probability distribution. So I should also mention you can do probability plots for many other distributions, the exponential, the Weibull, the log normal. It's just that most often we usually check data sets for normality because they're an assumption of some of the statistical hypothesis tests that we run. So that's why we're looking at normality. But if you were looking to see if an exponential was a good fit or a log normal, you would also see that the y-axis would be adjusted to meet the appropriate distribution. So what I'm hoping to happen, if a normal distribution fits this data, when I plot the ordered data against the observed cumulative frequency on the normal probability paper, I should see a fairly straight line, or I should be able to draw a straight line through those data points. So let me just draw a few, and then we're going to use some statistical software, because most often that's what you would do for these. So we go over here to 176, and I go up to position 5% of the time. Okay, so there's my first data value. At 183, that is 15%. At 185, that is 25%. At 190, that is 35%. Let's just do one more. 191, that's very close in here, is 45%. So I'm just going to continue to do this throughout all the points. And then again, if I can fit a fairly nice line through this data, which you can tell it's already looking like that would happen, then I can say, yeah, I can model this data adequately by a normal distribution. But again, I haven't finished. But just to give you the idea, and you could see this would be very tedious, especially as your data set gets larger, to do this by hand. So yeah, every statistical software package should have a nice program, at least for checking normality. So I did put this data in Minitab so I could show you how to do it in Minitab. So let's go and open the Minitab worksheet. I'm using Minitab 16. Thank you. Yes, we would like to see this. So let's go ahead and move the data into the screen so you can see it better there. Okay, there we go. Let's try that one more time. There we go. Okay, so here are the battery lifetimes. In Minitab, I've already positioned them. I sorted them. I found the cumulative distribution function. I found some z values such that the probability that a value is less than or equal to negative 1.64 is 0.05. There's another graph I could have drawn to show or to try to show you if normality existed. But again, I made the z column, but it's not necessary for this graph. So if we go to stat, you can see in basic statistics, there's a normality test right there. And that's probably the one you would go to most often. If you just want to test a couple different distributions, there's probability plot. So choosing this, I could test normality, exponential, Weibull, but since you're going to most often do normality, let's just use that one. So I go stat, basic stat, normality. My variable here is battery lifetime. These are just different normality tests. So I'm not worrying about that right now. And let's just go ahead and look at the plot. So you can see this went ahead and did pretty similar to what we were doing. I mean, the only difference here is sometimes the observed cumulative frequencies are computed with a slightly different formula in different statistical software packages or texts. But again, they plotted the data similar to how we were doing, and you can see a line fits this data fairly well. So I would say, if again, this is just a visual test at this point. Some people call it the fat pencil test. I'm a little bit against that because, you know, you could get a really fat pencil, but basically they'd say if you could take a fat pencil and lay it on the line and it covers most of the data, then that distribution models that data set fairly well. But there are other reasons that this is a good fit. And when you start learning more about hypothesis testing, the p-value is going to be your big indicator. But for now, we're going to say visually, we believe that these points lie fairly close to a line. And if you were to put an object along that line, it would cover most of those values. So in conclusion, what we did is we constructed a normal probability plot. I show you how to do it by hand, but I really believe you'll be going to some kind of statistical software to draw a normal probability plot for you. And again, what you're looking for is the axis has been changed, the y-axis, to match the appropriate distribution that you're testing. And in doing so, when you plot the data, the ordered observation data, it should lie fairly close to a line if that distribution adequately models that data set. So I hope that helps. Again, I'm really pushing for the statistical software in this case. And I think it's a great method. And again, it's going to be superior to your other graphing methods, especially, I mean, just for testing normality or testing if another distribution fits. You can get an idea from a histogram. You can get an idea from a stem and leaf. I don't want to say that, but this is definitely more reliable and visually, I'm going to say more accurate for making that determination. Okay, and so that is the end of this video, and I hope you've learned what a normal probability plot will do.